Good morning. This is Mrs. Dorless. Mr. Goings is out today, but we're still going to take our lecture notes and be able to move on. Today your lecture is about difference of squares and choosing a factoring method. So we're kind of combining two things into one, which is basically the concept of 8-5, which is I can factor difference of squares, and 8-6, I can choose an appropriate method for factoring a polynomial. I have an essential question here. What is the best method to factor? I think this question will be answered by the end of this lecture, so I'm sure that you shouldn't have any problem being able to answer it. Well, let's start out by taking a look at what difference of squares is. And we did mention this in Chapter 7 when we were looking at patterns a little bit, and it was the only pattern that we really wanted to learn. So let's just take a look at it again. If we remember that when we had two binomials where the first terms were the same and the last terms were the same, except that they had different signs, when we multiplied this out, we would get this a squared minus b squared. Remember, because we would multiply out a times a, there would be our a squared, a times negative b, that'd be negative ab, b times a, which is positive ab, and positive b times negative b, which would be that negative b squared. We can see that that middle term would disappear, and we would have just the first term and the last term squared with a minus sign underneath it. That's why it's called the difference of squares. So because of the difference, subtraction sign, and a square on each side. Sometimes we don't recognize it as easily, but hopefully in a moment I can show you a way that you can. So when we look at something like this, 9x squared minus 36, when we first look at it, we might not think this is a difference of squares, but because there are two terms, that kind of gives us a head up that it could be this pattern. Also because there is a minus sign, which refers to difference. The only thing that's going to throw us off a little bit is the 9 and the 36. But we can state those numbers, both of them, as squares. For example, 9 could be 3 squared, couldn't it? And 36 could be 6 squared. If I put everything else down right here, we can see back where we are. 3 squared x squared minus 6 squared. So we can see that every term is a square, which means we can factor this straight up. We can look at it, write down our two binomials, and take one of everything. So 3x and a 6, a 3x and a 6. And all we have to do is put different signs in the middle so that we will be able to go backwards, basically. Because remember, factoring is multiplying backwards. So we should be able to multiply that out and get us right back to where we started from. So let's take a look at some problems, and you guys are going to tell me yes or no if they are difference of squares. So here we go. Here's example number 1. X squared minus 25. Is this a difference of squares, yes or no? Well, two terms, so far so good. It's a difference, so far so good. X squared, that's nice. And then we also have a 25, which happens to be 5 squared. So for us, is this one? Yes, it is. So we write yes. Let's take a look at another one. X squared minus 24. Again, when we look at it, we would say two terms, looks good. Subtraction, looks good. Square term, looks good. And a 24, which isn't necessarily very good, but that's okay. Because when we know that that's not a square, here this isn't, right? So we can say no, it's not. So we can do that right off the bat. All right, let me get rid of this here. Okay, it's moving on. U squared minus v squared. Again, two terms, subtraction sign, squared term, squared term. Satisfies everything. So yes, it is a difference of squares. Now let's put down what this factors into, by the way. This would be u minus v and u plus v. Let's go back to this top one here and put what that would be. That would be x minus 5 and x plus 5. Okay. Now, when we say no to this, that basically means that it's not factorable. And it's possible we could come across something that's not factorable. All right, let's take a look at one more. X squared plus y squared. And again, we're looking at two terms, but it's an addition sign. Even though these are both squareds, it's an addition sign. So no, it's not factorable. Okay, so that's kind of helping us to see and decide what's going on, and that we can take a look at that. Let's try again a couple more just to make sure that we understand this idea. Let's make it a little bit more complicated. Maybe not. I think we just did this one, didn't we? Yes, we did. I think we just wanted to do yes or no before. So we know this one, so don't worry about it. We won't do that. Let's go to this next one here. 4x squared minus 16y squared. First we want to see, does it satisfy? And because it's two terms, that's so far so good. Subtraction sign, great. Squared, squared. We got to determine what's 4. Well, 4 is 2 squared, isn't it? And 16 is 4 squared. So when we go to factor this, we just need two binomials. Take one of each part into it, 2x and 4y, into each binomial as the first term and the second term. And one will put an addition sign, one will put a subtraction sign. It doesn't matter which one you put the addition sign and which one you put the subtraction sign because of the commutative property of multiplication. It just doesn't matter there. Okay, so now that we looked at difference of squares, the other part of our topic is choosing a factoring method. So let's kind of take a look at that. So I'm going to give you some steps. The best way to choose a factoring method. So let's go with step number 1. Step number 1 says we're going to look for a common factor to pull out. Okay? We're going to look for that common factor because that's going to help us make a quick factoring and also an easier factoring if we look for that common factor always first, because sometimes that could be hiding. Okay, step number 2. Step number 2 is going to be look at the number of terms that we have. And what do we mean by that? We want to decide, what are we looking at, a binomial, trinomial, or a polynomial, and that's going to help us decide how we're going to factor this. So, if we have two terms, we're going to look and check and see, is that the difference of squares? Okay, because if it's the difference of squares, then we know how to factor that. We just practiced that right now a moment ago. Okay? All right. So, let's go on to the next one. What happens when it's 3 terms? Well, when it's 3 terms, we have some options. Okay? We can say, will we use the diamond with this? Okay? Will we use the diamond, and can we use the diamond? Is it factorable that way? Okay? If it is, then we're going to go ahead and create our diamond, and we're going to find our numbers, put them in, find our other numbers, put them in, and use that to factor. Okay? Then if it's 4 terms, what are we going to do right away? We're going to head right away up to grouping. We're just going to start grouping from the get-go, which is part of doing the diamond, isn't it? Because we're just rewriting a trinomial into a polynomial so that we can do that. So our second step is look at the number of terms that we have. Okay, and step 3, which might seem kind of redundant, but always factor completely. Sometimes after you factor your binomial, let's say you did a trinomial and you factored it into 2 binomials, but one of your binomials can keep going. So you always want to look and see, especially just take a look at your binomials and say, hey, is there a common factor I forgot to put out? Or is this a difference of squares? You want to do that so that you can see what's happening. Okay? So let's take a look at this idea of always factoring completely. Okay, so if I take this x cubed minus 9x, and remember, if we follow the steps, we're going to say we're going to pull out a common factor. Well, what they have in common is an x. So I get left behind x squared minus 9. I don't want to stop at that point because I've got to check. This is a 2-term binomial here. And so we look at it and say, hey, you know what? That's a difference of squares. So I need to take this one step further and make this x minus 3 and x plus 3. And now I have factored completely. Let's try it one more time. Let's see what's over here. X to the fifth minus 16x. Don't let that fifth throw you, though, because we can still do this. Okay, what they have in common is an x, leaving behind x to the fourth minus 16. Now, at first you might think, well, that's not a square, it's a fourth power. But really, this here, if we can think about it, this is x squared, isn't it? So we need another set of binomials. So here we go. So we're going to go x times x squared minus 4 and x squared plus 4. Now again, you might think you're done, but take a look a little bit closer. This x squared minus 4 is a difference of squares. It will keep going. And it's almost like that factor tree, which I will show you in a second. Let's finish this up. X times, and then we'll factor this out. This will be x minus 2 and x plus 2. And this is x squared plus 4, so that's just going to stay right there. Get that in there. Okay. So, and if you can think of this almost like a factor tree, you know, if we do like the number 12, when we factor it, we don't just stop at 3 times 4 and say we're done. We take a look and say, can it keep going? And if it does, we will keep going with it. And that's kind of what we were doing with this second example. We're going to keep going until we can't go anymore. And again, just look at those binomials. Make sure there's no difference of squares hiding, or there's no common factor that you forgot to pull out originally. Okay, so that's the end of the lecture. You have an assignment which is going to be given to you, which is a worksheet. If you finish your worksheet, you should be putting together your packets. Also, you could be working on your processing skills, which are due tomorrow, which is skill 8.2a, 8.2b, 8-3, and 8-4.